Right lads, this is 2025 probability question, paper 2, section B, question 7, parts A, B and C here. So Sean is playing 2 tennis matches. He either wins or loses each match. The probability that he wins the first match is 0.6 and the probability that he wins the second match is 0.7. The outcomes of the 2 matches are independent, which means that one does not impact the other. They're completely independent events. So use this information then, write the probabilities in the boxes and do the associated, work out the probability for each outcome then. So in a question like this, just stepping on, this is 313 in your exam papers, might be different from year to year. So we're going to fill it in here. One of the big things here is probabilities should always sum to 1. So if you have 1 minus 0.6, if he's a 0.6 chance of winning, that's going to mean that he's a 0.4 chance of losing. Okay, as we go on independently here again, look, let's just say he won the first match, but it doesn't matter. His chances of winning the second match, he's a 0.7 chance of winning, so he's a 1 minus 0.7 chance of losing, which is 0.3. Filling in 0.3 there, and again he's got his win-lose scenario here, loses 0.3, 0.7 for winning. So that's these probabilities filled in here, and now we have to find out the probability of each particular outcome. So if he wins the match, winning the match is going to be 0.6, so win the first match and win the second match, that's going to be 0.6 by 0.7, right? So that's like probability of a win and the probability of win a second match there. Lovely jubbly. So then we've got the probability that's done for you already, 0.42. The next one is the probability that he wins the first match and the probability that he loses the second match. So that's 0.6 multiplied by, following on the branches of the tree here, by 0.3, and that turns out to be 0.18. The next scenario he has here, he could lose the first match and win the second match. So he could lose and then he could win. So losing is 0.4 the first match and winning is 0.7 the second match, and that's going to be 0.28. Right? And the last scenario here is that he loses both matches, probability of lose and probability of lose in the second match. So that's going to be 0.4 by 0.3, which is already calculated there to be 0.12. Job done, right? So moved on here. Based on the tree diagram, what is the probability that Sean wins at least one match? Now we need to be really careful here now. Winning at least one match. So as if I look at this here now, winning at least one match. So I suppose what I need to be thinking of here. Up here, he wins one match and he wins a second match. But what does the question say? That he wins at least one match, isn't it? Yeah? So would that count? If he wins both of them, he wins at least one match, wouldn't it? So that's going to be in our answer, right? That's going to be an answer. Now we come along again. He wins the first match, he loses the second match. Is that win at least one match? Yes. That's going to be in our answer. What about if he loses the first match and wins the second match? That's going to be in our answer because it says win at least one match. Even though he's won 2 up here, that's at least 1, so that counts as well. That's the big one there that people would miss out on. They think, oh, 2 matches, oh, that's not at least 1, but that is included. So, quite simply, that's our answer. 0.42 plus 0.18 plus 0.28. 0.42 plus 0.18 plus, is it 0.28? Yeah. And you get an answer of 0.88. Yeah? Done? Happy? Is that right? I didn't make a mistake there, job done. Next question. Sarah also plays tennis. Gee, she's a real all-rounder. Each time that Sarah plays a service game, the probability that wins is 0.78. Look at this again. So the probability that she wins is 0.78. The probability that she loses on her service game is 1 minus 0.78, which is 0.22. I really don't understand why they give this same type question. So, what is the probability that Sarah will lose her next service game? So, probability to lose, well, it's already, this is like relative frequency based on the data that we're just given. 0.22. Do you know? probability that she wins the service game is 0.78, and the probability that she loses the service game is 0.22, because 1 minus 0.78. Now, these are the beauty questions. I love these ones. What is the probability that the first service game that Sarah loses is her third service game? Always put this in English. So, first game. Second game. Third game. Right? We need her to lose on her third game. So that's probability of L, or no, maybe I'll leave it as L. So we want her to win her first service game, and we want her to win her second service game. And the way we say this, probability of win her first game, and the probability that she wins her second game, and the probability that she loses her third service game. Because what is the probability that her first service game that she loses is the third game? So, well, we know that's 0.78 chance of winning, and means multiplying probability with 0.78 chance of winning, and means multiply, and she's 0.22 chance of losing, which gives us an overall answer of, I don't know if anyone has a drum roll there or a calculator, you can do that answer for me. I'll take a drink.
1.78.
How much? 1.78? Yeah?
Yeah.
We sure? 1.78. Okay, is that right? Did you get that, Alan?
No, I got 0.133848.
0.134.
Ah, jeez, don't ruin my videos. What did you do wrong?
On the wrong way, I got it right. 134.
0.134. 0.134, what else? Because there's more, I'll round it in a second.
That's it rounded.
Oh, that's it rounded. Okay, that's it rounded. Done. Next question. Expected goals. And expected goals, is like finding the mean. It's like finding the mean. So all I'm going to do here is this. So this is the expected goals here in this match. An E here, normal E here, expected goals. And what I'm going to do is I'm going to get the sum of whatever each kind of value is for the shots multiplied by the probability of a possible goal, resulting in a goal, I think it's called there. So, long story short, it's like finding the mean. I'm going to multiply that by that, multiply that by that, and multiply that by that, multiply that by that. I'm going to add them all together, and there I get my answer. Job done. So, first one there is going to be, I have a 10%, so 6 shots in the match. They have a 10% chance of getting a goal. 0.1 when I say it, change it to decimal form. So that's not a great chance. 6 shots in the game. I had 15 shots, 6 of them had a 10% chance of getting a goal. Now, they had a very minute chance of being a goal, but not a great chance. Keeper should definitely be saving those ones. So, and add. So this fell up here means the sum of when I calculate here the number of shots for 6 shots had a 10% chance. When I do that, I then go and add up the next one and the next one and the next one. So 5 of the shots in the match had a 20%. So these are very low quality, I'd say here, very low quality shots. These ones here now, 5 shots had a 20% chance. Like on their own, 20%, not a great outcome, but 5 shots, that might lead to a goal. One of them might lead to a goal. 5 by 0.2 is 1 goal. Do you know? I might get 1 goal out of every 5 shots with the 20% chance. So they're kind of medium quality. Might be, I don't know, like whatever, medium quality. Moving up the game here now, we have a 40% chance of scoring from 3 shots that we take. So 3 of the shots in the match had a 40% chance of going into the back of the net. Again, that's a decent quality, I would say there. Now you might be saying, no, like 1 should be decent quality or 0.75. Not really, you got to think like 40% chance. That'd be kind of nearly inside the box, you know. You'd have an okay chance there. And then 70%, well that's high quality. That'd be nearly like a penalty kick, do you know, or not far off it. I know you might be saying, 89, like 90% would be a tap in. You'd be on the line because someone crosses it in, you should be able to tap it into the net. So 70% might be like a penalty kick. You only had 1 of them in the game, So that's 1 by, you had a 70% chance of scoring that one. So we work these out, we get 0.6, or you can just do it all in one go. 0.2, and we get 0.7, and I don't know what else you get there, you get 9, 2.9, 3.5. Is it?
Yeah.
So from those 15 shots, how many goals do we expect to get? 3.5 goals. Now you might be saying you can't get half a goal in a match. That's not the point of this, lads. This is statistics. This is saying that if you took 30 shots, you should be able to get 7 goals. Right? Double it up. Double up the 3.5, double up the 15 shots. Do you know what I mean? This is statistics giving you an average of what should happen. Not exact science behind it. We all know that you can only get 1 goal, 2 goals, 3 goals, 4 goals. And that, I think, is 2025 done. Yep, beautiful, on the way. Okay, hopefully that would help, is it? No? Right, I couldn't remember mistakes, they're doing that live now, lads, is that right? Oh, sure, look, I'm